Hare Krishna. Hope you're doing well. Let's get started with this question on probability computation, where we are given two random variables from the Poisson distribution, and a new random variable is defined as the minimum of these two. And we have to compute the probability associated with this new random variable. Now, first, let's write the probability in a slightly different way. This minus this. The way this works is the minimum of xy greater than equal to 1 is all the probability masses 1, 2, 3 onwards, and similarly for greater than equal to 2 it's 2, 3, 4, 5, 6 onwards. So once we subtract these two we are left with this only. Now you may ask, why write this simple looking probability like this? The reason is it will help us do the computation over here better, and this thing can be written as this because very important to remember. Think of it like this: you have a team, and the weakest member of the team is able to defeat somebody. So if the weakest member can do it, then every member in the team can do it. So that's what the intuition is over here. So the minimum would be greater than equal to 1 only if both the random variables would be greater than equal to 1. And this can be written in a simpler form like this. And based on Poisson distribution with mean 1, we know that probability of that variable being 0 is going to be E inverse. And similarly for greater than equal to 2, we write it as the square of this, and it's a square because the same thing that is happening for x would happen for y, so it's the product of these two, the square. And once we figure out the Poisson masses at 0 and 1, they are the same, E inverse, we get this. And now we plug these two back in the original expression, and with some simple algebraic computation, essentially a square minus b square equals to a minus b times a plus b, we can arrive at this. And the last thing we do is just multiply and divide by e square, which gives us this, and this is the answer. So that was it, and take care. Hare Krishna.